Hi, my name is Scott Lee from Super Team Korea. I'm honored to moderate one of a great panel session. The topic here we're going to be discussing is called security blind spots, but you're overlooking until it's too late. So there has been a couple of incidents, hackings all the time, but we have the experts here, and we would like to discuss, how they're kind of solving the problems and protect your assets in this field. So first of all, can you go around and introduce yourself? Matthew?
Yeah. Hello, everyone. This is Matthew, and I'm the audit team in BlockSec. BlockSec is founded by top-notch researchers in 2021, and we provide the full lifecycle security services. We do audit. We also have a great product named the Falcon, which can monitor the attacks in real time and block the hacks. After that, we also have some forensic tools like MetaStools. Yeah, thank you.
Yeah, I think that's a typo. That's not Jumbo. It's supposed to be BlockSec, but just wanted to correct.
Yeah.
Hey everyone, it's Isaac. I do security solutions at Cantina. We do audits from end to end, so we do cover competitions and bounties as well. And also we do almost ecosystems, as we came from a huge compiler background.
Hi everyone, I'm Yannick, co-founder and CEO at Archium, and with Archium we are building what we call the encrypted supercomputer, so you can think of it as a network extension to Solana that enables all types of computations to be executed over fully encrypted data without having to reveal any of the underlying data to anyone.
Awesome.
So I just want to connect that this should be BlockSec instead of Jumbo. Yeah, small mistake.
Oh, okay. Got it. Okay. Yeah, I'll start with a very general question. So, in your guys' experience, what is the single most common security blind spot that builders in the blockchain or Web3 space tend to overlook in the early stage of development? So I think it's a good question for builders when you're building a product.
Yeah, I think most of the developers in the early stage may have over-reliance on the final auditing, but actually the security should last in the full life cycle from the original product design to the final deployment. Every step there's attack surfaces, and many developers they might thought that audit is very easy, and they might do it in a rush. They develop their codes and rush us to audit maybe within just a few days, which results in the poor quality. So yeah, I think you should be aware that the security is very important in the paramount in the every life cycle across the whole product design.
I feel like testing itself is one of the huge factors, but I'll take a different tangent, which is the product design. Everyone wants to design like an interesting product with a very weird or like unique way to approach the market. Sometimes these designs usually backfire once the final product is ready, and said design might be innovative and special, but in the security side, it will pose like a huge risk to all the users, even though it sounds interesting to investors.
Yeah, so I think in regards to what we are trying to achieve with Archium is in general removing the dependence on single points of failure. So I think within a lot of architectures, if you look closely, you can actually identify a lot of single points of failure. That starts with signing and upgrade authorities for smart contracts, for programs on Solana, and ends, I guess, with realizing that there isn't just a risk for assets, but there's also a risk for data, for example, to be leaked. And so in general, what we are trying to push for with Archium is to utilize things like encrypted computing to be able to remove single points of failure, to be able to remove the dependence on some single actor performing upgrades or performing these kinds of computations. So what we utilize at Archium cryptographically for that is secure multi-party computation, which allows a set of participants within Archium, our network, to run encrypted computations on behalf of other users. And that can mean that these kinds of computations can be executed in order to perform some actions for the protocol, which can be managing assets, which can be upgrading things, which can be running computations in a privacy-preserving way as well. So I think in general, what people can realize and should realize is that there isn't a need anymore to rely on single points of failure.
Awesome. So usually, when there is a hacking or exploit, it's usually around a small contract. So there is always hidden risk and attack vectors. What are some of the more subtle or emerging attack vectors that you guys believe that are not receiving enough attention right now in this space?
Yeah, I think despite the well-known smart contract vulnerabilities, there are several kinds of attack factors. For example, the very important configuration. This might not in the daily operation and the maintenance. For example, for a lending protocol, the lending rate is very important, but several maintainers might not be aware of that, and they say if they set an inaccurate rate or improper rate, the protocol may suffer a loss. And by the way, I think also the private key is also very important, but actually many protocols may not have a very safe mechanism on keep their private key confidential. This is also very important.
It really depends on the client itself or like the project. If it's math heavy, there's a lot of precision errors that might happen. But I feel like to generalize for every project, I feel even simple OPSEC would play a huge role in like securing wallets, even simple upgrade authorities. It's always the simple stuff that people forget about that somehow results in the biggest hacks happen. Like even if you look at the recent hacks that happened, a lot of them are very simple human errors that is probably not on the code itself, but more on them not securing the wallet properly, not having a proper multi-sig setup, etc.
Yeah, I agree that I think for teams to not get exploited, not get hacked, I think the essential precondition is the mindset that the developers and builders take, right? That your mindset is that, okay, when I do some on-chain arithmetic, I need to ensure that this arithmetic is checked, right? And I think to speak to your point is important is that in general, what we should strive for is to remove the need for aspects in our architectures, I guess, where there is this requirement of some user being able to exploit social engineering, right? What we should have instead is a programmable way of managing all of those things. So if we, for example, look at the Coinbase exploit, where not assets were stolen, but user data was stolen, that was done by socially engineering some of the employees and getting them to transmit data, right? An alternative approach to compliance could be not even giving those employees access to the sensitive data, but instead employing computations over all of that sensitive data that doesn't expose the data. So I think we are still far from eliminating all of those single points of failure, but from a technological standpoint, we can already enable those things.
Yeah, so we'll do a more deep dive questions for each the project. So first questions goes to Matthew. BlockSec is well known for its real-time monitoring and incident response capabilities. So given your insights from the incidents like Bybit or KyberSwap that happened here, how critical is proactive real-time threat detection versus post-mortem analysis in mitigating an impact of an attack? And also the second question is, can you share a specific example where real-time detection made a significant difference?
Yes, thank you. Very great question. Actually, for both KyberSwap and the Bybit, the incidents, actually, if they have a proper mechanism, both of these loss can be mitigated and can reduce in a very small value. If I remember correctly, for the Bybit, the root cause of the hack is that the front end is hacked. They signed an incorrect transaction and just move the owner to the attacker's address. But if they simulate the original transactions, they signed, they will know that is a suspicious transactions. And for KyberSwap, actually the whole transaction, the attack transactions consist of 23 different kinds of transactions among maybe 5 or 6 different kind of chains. So if they have a real-time monitoring system backup, once the first attack transaction is monitored, they can automatically pause all the protocols across all the chains. Then the loss can be reduced. Actually, we monitor the first attack transaction, and we connect the Kyber swap team at a very early stage, but they are in sleep, and they don't have automatic response. So the attackers just keep attacking, and then finally resulting a loss of around $48 million. Yeah, as for the specific example, actually, BlockSec has public no record that rescued about more than $20 million. We rescued several kinds of protocols previously. For example, 2 years ago, we rescued about $5 million per paraswap. The fundamental idea is that we have a product named Falcon. We will monitor the transactions in the memory pool, and we detect whether the transaction is a suspicious one or it is an attack transaction. If so, we will fork the transactions and front-run the attackers. That's the fundamental idea of how we conduct the rescue, and it works. Thank you.
Yeah, that's a really good answer. He covered a lot of the wide spectrum of how they kind of help the builders when it comes down to security. Going back to Isaac, I know Sparabit focuses heavily on security auditing and penetrating testing. So in the context of, overlooking security until it's too late, where do you see the biggest gaps in auditing process itself that might allow critical vulnerabilities to slip through? Are there specific methodologies or approaches that are often neglected?
So in the industry nowadays, people just go for audit for the sake of it because the investors push them to do it. People should not take security as like a mandatory step to go to market, but a mandatory step to secure your whole protocol's longevity. You should always take the audits very seriously. Look at what the perspective the audit is looking at. So sometimes the dev will think like, okay, this specific functions might pose a threat, but once the code goes through the audit and once you have like real-time interaction with the auditors, you realize the audits are looking at totally different stuff, and the things that they look at could have posed a serious threat than the devs might understand sometimes. And the security people also will have like a more different perspective from the devs, as they would look at areas where the threats will actually have to happen instead of what the developers think the functionality is.
Got it. I have one more question for you, since you're an engineer. From your perspective, how can teams effectively integrate security, features, or from the design phase onwards, rather than treating them as an afterthought?
I can give like a few suggestions, and I also can give like an example. So a good suggestion would be having security always be a part of consideration during design phase. You need to expect like if someone exploits our contracts, what tangent will they work on? What angle will they go against in terms of our code base? And to mitigate that issues, you can work towards doing invariant checking for each transaction that is done. For example, Euler v2 does a similar thing where every single transaction sent, it will simulate the transaction first to check whether the output is the same as expected. If it's not expected, then something went wrong, the transaction will revert automatically. So that was a good example because I think we all know why Euler is very security conscious. They would take these steps and implement it in the protocol level so that by design, they are super secure.
Awesome. Thank you for the answer. Back to Yannick. So RCM's focus is on heavily on confidential computing and protecting sensitive data. So how does RCM technology directly address the hidden risk and attack vectors that arise from exposing sensitive data or computation within traditional blockchain environment? And secondly, if you can give an example of you spotting some of the exploits or help to illuminate and secure.
Yeah, so Arcium in general is this network, a stateless computing network that itself is being partitioned into what we call computational clusters, and those arbitrarily large computational clusters then run those secure multi-party computations. And those get executed in the lowest possible trust model. So we've designed a new protocol for this that operates in so-called dishonest majority. So you always, as a trust assumption, only have that within this arbitrarily large set, there exists one arbitrary honest actor that acts according to the protocol. And since it's permissionless, anyone can become this single honest required participant. And our network then can be used both off-chain and on-chain. And when it's being used on-chain, developers can use Archium within their programs and simply specify what state and what functions should be encrypted. And I guess one of the first big things, I guess, that we've enabled developers is to not have to worry about the underlying cryptography themselves. I think that's one of the big areas where teams, I guess, necessarily will fail, because not everyone has a PhD in cryptography and can think about all of the potential attack vectors in handling this kind of complex cryptography. And so we are trying to abstract all of that away from the developer. We, for example, build a custom Rust interpreter for this, so developers don't have to write some low-level cryptography, but instead can, on a high level, specify what should be encrypted, what should be private, what should be public. And the I guess, solutions that we bring with Archium aren't just some user, some institution has sensitive information and they don't want that to be public on chain. I think that's one aspect. But again, as I mentioned earlier, I think we really need to think in this model of eliminating single points of failure. And the way you can think of those clusters within Archium executing those computations is you have some data, which I guess could be a private key, right? And you give this private key to this network that can't see your private key, and you define the rules under which this private key can be used, right? And so you can create those autonomously executing environments that execute based on some rule set that you've defined. And that rule set can be, okay, a user can pass an encrypted order, and then your program using Archium is able to match orders without anyone seeing who are the participants submitting those orders, what are the details. At the same time, that also means that users can, for example, put data in there, and then Archium is being used to train machine learning models. But again, it can also be more on the security side of things, where you're like, okay, I have some key that is being used to, let's say, decrypt some data or to sign some information, and I want that key to be managed in the most secure way possible. And so I think what also speaks to that point is that we have to think about security not just in the sense of asset security, but as with the Coinbase example, I think security also is important in regards to data itself, in regards to KYC data, compliance data, customer data, right? And so what we're trying to achieve with Archium is that all of this kind of data can be managed securely by keeping it away from any prying eyes, from not having any single computer in the world that has access to that data, while at the same time we're able to process that data. I think that's one important aspect. So you're not just taking your data and saying, okay, I'm afraid of that data being exploited, so I just keep it locally on my device or encrypt it, but instead with Archium, you encrypt it in a way where we can still process all of that data without anyone seeing it.
Awesome. Because of the time, I think this will be the last question. We've all seen how the CEO of Bybit reacted to the community. He was being very transparent after their wallet was compromised. I mean, I think he did a really good job telling the communities what would actually happen on a chronological order. So, given, how he reacted, I think rebuilding trust is a monumental task after all this kind of hacks and the security incident, right? So beyond all technical approaches and advice and fixes, what are the key non-technical strategies or communication strategies that you guys believe that all the founders or the projects should be addressing, and that is essential for a project to regain the user's trust after the incident?
Yeah, I think it's better you do not have the strategy in practical practice, because otherwise your protocol got hacked, right? So I think first of all, you need to make everything transparent and prepare a thorough post-mortem analysis, tell the user why it is hacked and what is the root cause and what you are going to do to compensate your users. And for example, you may use your revenue to compensate your protocol, your users, and you may engage with the party auditors and to evaluate your protocols again. And also you may need to launch the bug bounty program, and you also apply some real-time monitoring systems to ensure that the similar hacks may not happen anymore. Yeah, that's it.
Isaac?
I feel like when it comes to the community, especially after a hack just happened, the most important thing to do is to be quick. Once the hack happened, everyone will speculate on what happened. Everyone will say it's the protocol's fault. They didn't manage things properly. So it's really on to the protocol to give a swift and transparent answer on how they're tackling it, why this happened, and give them everything that they would have found out either way. Because if you give like a few hours of time, that community damage based on speculation is already enough to hurt most of the users. That paranoia in that specific time, I feel like you have to mitigate it to the lowest possible. At least that's on the community and like how you manage post-hack.
I can't speak to any communication strategies, I guess, but the way I think about it in general is, especially when we are talking about centralized actors, centralized exchanges that necessarily have some centralized elements in their entire architectures, would be to employ more safe cryptographic systems. I think in the case of exchanges, that's something like implementing proof of reserve schemes, where there is a higher level of default transparency, and then it's way easier to establish trust because the underlying systems themselves have a higher level of trustlessness, right? And so if I don't have to trust someone, I can trust them.
Awesome. I think we got a few minutes left. Before I let you guys go, I'll finish with the last question. So looking forward, looking ahead, what's one major trend or innovation, sort of trending tech in blockchain security that gives you hope for the future?
I think, first of all, more developers are coming, devote themselves into the Web3 world, and they are awareness of the importance of the security and across the whole life cycle of the protocols. They understand the value of the security, and they learn what is the role of security plays in the whole product design. This might be a good trend. Yeah.
Isaac?
In terms of technology, I would say maybe this is a bit broad, but zero-knowledge proofs is probably the best thing that I feel could be implemented well. I think even typical Web2 companies are adopting it. And in terms of security, just bringing privacy and security together, it brings a whole different mechanism to secure projects altogether. You don't have to review much information. You can just get everything proved by a verifier. I feel like that's the future we're heading. And eventually it'll be pretty safe, especially when the risk is information at the end of the day.
Yeah, I think what gives hope, and I think what is an exciting thing to look forward to, is that if we do it right and employ these kinds of cryptographic systems, if we employ decentralization right, we can have both more powerful applications, and we can get rid of all of those issues that we see within centralized infrastructure, right? I think initially the entire space started because there was this high dependence on centralized actors. There were all of those issues, and to some degree it has felt like over the last few years that those issues have been replicated in crypto as well, where there always have been centralized actors that get exploited. And so I think if we embrace the kind of technology, and crypto as the space has moved all of this kind of technology forward tremendously, we can get rid of all of those issues. And those issues include, for example, data leaks. So that's still one of the big problems that we face in Web 2 and in Web 3 as well. And it's also one of the big hindrances for institutional and retail adoption of this technology. So I think in general, privacy technology, but not just privacy technology, but what we call privacy 2.0, where it's possible to compute over sensitive encrypted information without having to reveal it. And I guess that's what I'm most excited about, this, I guess, synergy between distributed computing and cryptography.
Awesome. So thank you for your insights. It was a great panel. So thank you for listening. I hope you enjoy the rest of the day. Thank you.